Hello guys, so let's continue with Facebook coding questions. And today we're gonna start with question 5 to 8, random pick with weight. So we're gonna skip these three questions as they are too easy. So let's start it. All right, so for this question, we're gonna be given a zero indexed array of positive integers, W, where Wi indicates the weight of ith item. So here, positive integers means integers which is larger than zero, or larger than or equal to one. So we can know we know all the values in the array will be larger than or equal to one. That they are integers, and then we're gonna write a function that can randomly pick an index in the range with the probability of picking that index with the probability of the weight of that item divided by the total sum of the weights of all the items. So for example, if we have an input of 1 and 3, then the probability of picking the first item will be 0.25 and the probability of picking the second item of 0.75. So to solve this problem, let's start it with a sample input of maybe 1, 2, 3, 2, and 2. So let's say we have an input array of these items. So what I can do is we can generate a new array of the running sum of all the items up to the current item. So let's say the first item or the first value will be 1, which is the sum of all the items before this first index. And then the second one will be 3, which is the sum of 1 and 2. And then the third item will be 6, which is the sum of the first 3 items. And then the next value will be 8, which is the sum of all the first 4 items. And then followed by 10, which is the sum of all the 5 items. So what we can do next is we can randomly pick a value between 1 and 10 inclusive, include 1 and 10. So both are inclusive. So let's say we generated a random number between 1 and 10, which is 7. So which is here, right? And then we can just pick the largest number, a smallest number, which is larger than or equal to 7, which is 8. So 8 will be which is the fourth index. The fourth item will be the one we return when we randomly generated the 7 between 1 and 10. So how does it work? So let's say the first let's say we for in this way, right? So if we want to pick the fourth item, then the only probability of picking the fourth item is we can get 7 or 8. So if we generated 7 or 8, then we pick the fourth item. If we generated 9 or 10, then we pick the fifth item. If we generated 4, 5, 6, then we pick the third item, right? So this matches the probability, 7 and 8, which is 2, right? And then 1 to 10, which is 10 numbers. So these two numbers, if we randomly pick one from 10, and then if we pick the 7 or 8, then we can return the fourth item. So this matches the probability, 2 divided by 10. So all the numbers between 6 and 8, exclude 6, include 8, will return the fourth index. All the numbers within this range will pick the third item, will return the third index, and all the values within this range will pick the second index. So this will actually matches the probability as long as we find the smallest number, which is larger than or equal to the target value generated by the random picker between the range. So how to find the smallest value larger than or equal to the target in the array? And this array is sorted because we are doing a running sum over the past values. So this must be increasing. So this is an increasing. This is a increasing array. So which means this value is sorted and will always increase. So to find a target value in the sorted array, what we can do is to do binary search. So we can use binary search to solve this problem. So as long as we generate the target array, And we can just randomly pick a number within the range and then do binary search to do that. So I have a median block, which is here. So this median block will give you all the binary search algorithms. Like for example, if we have an array and like with unique items, we sorted the array with unique items, and we want to find the exact match of the target value, then we can do this. And if we have an array with sorted values but has duplicate items, like has lots of value 2s and 3s in the array, then we want to find the first match. Like if we have target value of 2 and we have many 2s in the array, then and we want to find the first 2, then we can use we can do this algorithm. And if we want to find the last 2, the last match, like we have lots of 2s and we have a target value of 2, and if we want to find the last 2 in the array, then we can do this. And then also, like, we want to find the largest value smaller than the target. So let's say we have an array of 5 and 7, and we have target value of 6, and we want to find the largest value smaller than 6, which is 5, then we can use this algorithm. And the same, if we want to find the smallest value larger than the target, then we can use this algorithm. And this is what we're going to use for this coding question. And also, if we want to find the minimum difference with the target, then we can use this array. Let's say like we have in the array, we have like 10 and 20, and then the target value is 18. So we want to return 20 because the difference between 18 and 20 is 2, which is smaller than 10 and 18, which is 8. So we want to find the minimum difference. We want to find the item with the minimum difference with the target. Then we just use this algorithm. Okay, so go back to the Leetcode question. Let's try to solve it. All right. So first in init, we want to generate the new array, which has the running sum, like the running sum of all the items. So we can just say self. We can just generate a new array. Let's say sums. And then we can have a current sum. Current sum equals to 0. And then for I, let's just make it for item in all the weights, then the current sum will become the item, and then we just append it to the sums. And current sum. All right, so now we generated the new array with the running sum, and it's a sorted array. So now we just need to do the binary search to find the smallest value larger than or equal to the target value. All right, so let's first let's get the target value, which is a random generator. So we need to import random. All right. Okay, so let's say the target value will be random integer within the range of 1. Okay, sorry. Right, 1, and the total weight will be the self sums, the last value here. Okay. So this will generate a number between 1 and the total sum. Both include 1 and the total sum, inclusive on both sides. All right, and then the low index will be 0. So this is the lower side, and then the higher side index will be the length of self dot sums and -1. Okay, and then now we just do binary search between the low and the high. So let's say return response is this. If it doesn't exist, then we just return the response -1. And then like while low is less than or equal to high, while low less than equal to high, then the midpoint will be low, plus, sorry, the low plus high divided by 2. That's the midpoint. So if the self dot sums, the midpoint is equal to the target, then what we can do is like we just return the mid index. So this is the index we're gonna return. Like we pick the, like we find the match, and L if the value, let me actually do this so that we can have less duplicate code. If value is smaller than the target, if it's smaller than the target, then if it's smaller than the target, then we need to set the lower bound to be the mid plus 1. If it's smaller, because the lower bound must be mid, the mid won't include, because we want to find the mid value is smaller than the target. So we want to find the value which is at least larger than or equal to the target. So the mid won't be included. So that's why it's plus 1 here. This is the reason why we have plus 1. Otherwise, we can set the response to the mid. So the mid might be the actual value we find. So we just set it temporarily, and it will be keep updated in the while loop. And then also the higher bound will become the mid minus 1, because we already set the response return value to the mid. So that's why we just make the higher value to mid minus 1 to exclude the mid in the next while loop. While we are looping, we just exclude the mid on the loop so that it can break out if it doesn't match. And then we just return the response, and let's see how it goes. All right, and it matches. So okay, so time complexity wise, space wise, it will be order of n, because we're gonna have a sum array, new array with length of n, and the time complexity wise, it will be log of n. Log n, because the binary search is log n. And yeah, so this is basically the code for that. And I also attach the link to my Medium blog regarding binary searches in the description of the video as well. And I'll see you in the next question.